guys, what's next on the test is going to be a lot of calorimetry type problems, right? And calorimetry is not that bad, okay? Measurement of calories, okay? We know we're familiar with calories from food and so on, right? Okay? And we know we don't want to ingest too much because, dieting and health considerations, right? No problem. Now, nice thing is, let's say we have this calorimeter right here, right? Now, you're going to use your imagination because my artistry skills are kind of, suspect. So, you have a chamber in here, right, with a dehydrated food sample, right? Now, connected to that food sample would be some wires, right? And that's connected to a power source. They are going to ignite, okay, the food sample, and it's going to undergo a chemical reaction, normally a combustion reaction. Now, it just so happens, right, there is water inside of the calorimeter, very important, right? Now, what's going to happen is, when this food sample, right, undergoes an exothermic reaction, okay, it's releasing energy into the water. What do you expect to happen to the temperature? Let's say the temperature is at 25 degrees initially, right? And the calorimeter, okay, is experiencing an exothermic reaction in relation to this food in the chamber, okay? We expect the water to warm up, yes? Okay. So that particular temperature at 25 degrees, it's not going to stay there. It's going to go up by some certain amount. It's going to change by some certain amount, okay? So that's where you're going to get this guy right here, delta T, all right? Now that's going to be important to us in a second, because if you look on your reference tables, you will see this equation. Q equals to M times C times delta T, right? Now, I normally use it, okay, like this, where Q, the triangle, Q is equal to MC delta T, okay? Q on the top right here is equal to mass times C, which is specific heat, times delta T. Now, before we do any problems, people, you have to know what each of these variables mean. Okay, Q stands for heat energy, okay? And you also have to know the units, guys. It's normally given to you in joules, sometimes it's given to you in kilojoules. If it's given to you in kilojoules, you simply convert it to joules and you continue working from there. But you gotta know what the units represent in terms of the different variables, because then you start mixing matching, then it goes downhill, okay? Alrighty. Our good friend M is mass, okay? So we use the unit of grams for mass. But let's say your teacher gives you kilograms, you don't panic, you convert it back to grams, all right? Remember you learned metric conversions, right? Okay, King Henry died by drinking chocolate milk, moving decimal, okay. Delta T, as we just discussed, represents temperature, TMP for short, change, okay? Now, I'm presuming all this information is on the back of your reference table, so use it carefully, use it wisely, right? Okay, and this guy C right here stands for specific, okay, heat capacity, okay? And it's simply the amount of heat energy needed to raise by 1 degree 1 unit of sample. So I'll keep it simple. Let's say we have a block right here, right? And this block is, 1 gram, okay? And it's at 15 degrees. Let's make up a number. The energy needed, right, the Q needed to raise this from 15 degrees to 16 degrees C, that's called the specific heat capacity of that substance. Now, if it's a metal block, metals tend to have low specific heat capacities, okay? And something like water now, on the flip side, would have a very high specific heat capacity. And that's why aquatic life and humans are able to live, okay, because the high specific heat capacity of water. Because if it didn't, okay, we will just boil away and return into prunes, right? And lakes and the ponds will be frozen over. So we'll talk about that later on in terms of using this equation where Q is equal to M times C times delta T. We'll look at how to isolate the variables. We'll look at how to find what to determine what we're looking for, and choose the information from, okay, the question to answer the question properly. Because once again, if you just guess and put this there and put that over there, okay, it's not gonna go well. Okay, so we'll do that in a second. Alrighty.